Okay, Engineering 110. This exercise focuses on getting some practice working with files. So we already have some videos posted on how to read and write from a file. But in this video, I want to show you how you can calculate something that might be of interest. So I've got two sets of data. One set of data is 2370. Maybe these represent the amount of hours of sun that a particular location got for 4 days. And another set of data is 3333. So if you were just writing a program to get the average of these two sets of data, the average of this set on the left, the average of these four numbers, the average of those numbers would be 3. 7 and 5 is 12. 12 divided by 4 is 3. The average of these four numbers is 3. But clearly these are different. There's something different about these sets of data. They both have the same average, but the data set on the left has a lot more spread to it. The data on the right seems to be pretty consistently 3, and the data on the left is sometimes too big, sometimes too small. So what we'd like to do here is find a way to not just get the average, which we've already done, and to get the average, that's the level C task. I want you to read some data from a file called temperatures.txt, which is attached to the Blackboard site, and calculate the average. But let's also see if we can calculate a measure of the spread of the data. So what I'd like to do for each data point, after we've calculated the average, we can go back in and calculate how far away each number is from the average. So that 2 is down 1 from the average, the 3 is equal to the average, the 7 is 4 bigger than the average, and the 0 is down 3. Now, of course, these data are all not deviating at all from the average. Okay, now what if to find a measure of the spread of the data, what if I just added all those numbers up? So I add a -1, a 4, a -3. If I just added all the numbers up, I'd end up getting a 0. And if I added up those numbers, I'd end up getting a 0. So I think that's a bad way to do it. In fact, you're always just going to get a 0. So what we can do to see if we can pick out a measure of the spread of the data, there's kind of two ways you can think of. One might be to add up the absolute values of these numbers, but that can get a little bit clumsy sometimes. Or another way to achieve that is to take each of these numbers and square it before adding them together. So if we square all these numbers, that'll make all of them positive. So let's square all these numbers and then add them all together. So that would be a 1 plus a 16, which is a 17, plus a 9, which would be a 26. And then we can take the square root of all that. Okay? And, oops, nope, didn't want to take the square root yet. Before we take the square root, let's first divide by the number of numbers, because if I take more samples, I don't want that to make me think I necessarily have a greater spread of the data. So instead, we want it to be kind of on a per measurement basis. So we should divide this by 4 samples, and then to kind of undo that squaring effect, let's take a square root. So this right here, we're going to call this will be our measurement of the spread of the data, which we'll call the standard deviation. So in our case, that would work out to be the square root of 26 over 4, which is 2.55. All right, so I want you to write some code that takes that same temperatures.txt data and calculates an estimate for the spread, or this sometimes referred to as the standard deviation. All right.